Hello everyone, welcome to another video. Today we're going to be solving a resolution of vectors question where they ask us to first draw the vector, then they ask us to find its magnitude, and finally find the angle of travel. And they give us what the vector is here. So just doing question 1 first. We're going to notice that there is minus 10 in the I direction, 60 in the J direction, and because it doesn't mention anything, we're going to assume that there's nothing in the K direction. So computing this out now, we're first going to draw the vector. So X is also known as I, and Y is also known as J. So we're going to go minus 10 in the I direction, and then we're going to go up 60 in the J direction. So this is the point that we want, and we're just going to draw the vector. That is the vector we are after. So I've just removed the other two vectors because we don't need them anymore. But here we're going to label this V. Great. So what is its magnitude? How do we calculate the magnitude? Well, the magnitude of any vector is equal to the square of its square root of its components, which means square root v1 squared plus v2 squared plus v3 squared plus etc. The square root of its components. So we're basically going to do exactly that. And we know that v1 is our x direction, v2 is our j direction, and v3 is our z direction. So the magnitude of v is equal to v1 squared, which is minus 10 squared, plus v2 squared, which is 60 squared, plus v3 squared, which is 0 squared. And we're working in 3 dimensions here, so we do not have any extra dimensions of v3. That fancy stuff you're going to find out later in maybe year 3 or year 4 when you do general relativity. So again, the components of v is just square root of 100 plus 60 squared, which I believe is, I think, 3,600. And that's equal to, get the calculator out for that, 60.827 meters. So that's approximately equal to 61 meters per second. Great, so we have done question 1. We're done question 2. Now we have to find question 3. So we want to find the angle of travel. So clearly I think it's basically going in this direction. So we want to find how much of it's going in the majority of the direction. So I guess we can define this angle. If my drawing works. There we go. And let's call it theta. And zooming into this, we just use our law of SOHCAHTOA from high school, and that is going to give us the exact value of theta. So just going to draw that triangle out again to make it more clear. So that's our vector v. here we know that this is 10, and we know that this is 60. We're going to ignore the minus sign here, just so that we can actually compute our trigonometric functions. So just finishing the triangle, we want this angle over here, 10, 60. So let's see, 10 theta is equal to opposite over hypotenuse. No, it's equal to opposite over adjacent. So let's see, 10 over 60. And for theta is equal to arctan 1 over 6. Another way of writing arctan is just tan inverse, but after you take more math, you will start using arctan more. So I am just getting you used to that notation. So there you go. Computing that arctan into our calculator, we get 9.5 degrees. So those are our final answers. And I suppose I can just do that. Great. Now on its own, this question you might find not too difficult, but as you start combining this question with additional elements like force diagrams or even moment of inertia or angular momentum, then it's useful to have this system nailed down just so you understand exactly what's happening. So that's it for today. Thank you everyone for watching my video. Goodbye.